in mechanic, electrical, whenever they saw homework, they share the home. Whenever they saw the exam, they share the answer. So, but we don't have that problem, but it's just an example that all of them contribute, all of them. Whenever we had a building, whatever happens on the floor that you are, has influence to the floor above and to the floor below, as long as the structure is indeterminate. So whatever happens in one floor has influence the floor above and below. And after that, it can move into the other floor above and the other below. So all of them contribute, of course. The one that are closer to the load are the ones that work the hardest. So to solve this problem, what we're gonna compute is what we call the moments at the end of each member. So we're gonna compute the moments at the end of each member, and with that, we're gonna compute later the reactions and do the shear and the moment. So we assume that all the moments are clockwise. To start this problem, we assume that all the moments are clockwise. That's why I put it here, look. I'm calling this moment AB. I'm calling this moment from B to A. I'm calling this moment from B to C and from C to B. So we assume that all of these moments, they are clockwise. Based on the sign convention that we discussed, you need to put a sign to what I'm telling you. All of these moments are of the same sign. Are they positive or negative? What are we assuming? Positive. All of them we are assuming that it's positive. So we have the moment from A to B, the moment from B to A, B to C. And after that, we look, do I have a theta? Look, this is fixed support. Do we have a theta 8 in here? Or is zero? Anybody? Do we have a theta, a rotation at A? Anybody? No, there is no rotation because that is a wall, is a fixed support. So there is no rotation. It's fixed. That's right. So at B, look, this is an elastic member. Do I have a rotation at theta B or is zero? Anybody? Miguel or Bijo, anybody? Yes. There is a theta B in here and only one theta B. And when we look at this wall, theta C is zero. That's why I put it here. Theta A, zero, theta B different at zero, and theta C. It reduces the number of unknowns. Also, there's no support moment, this is zero. I put a note for you to remember. We're assuming all the moments at the end of the member positive. That's why I'm assuming clockwise. We need to compute the fixed end moment. And this table sometimes I'm gonna combine in a question 2 or 3 different loads. So if I had 3 or 4 different loads, you just look at all the cases and you add them or subtract depending on the direction of the load. Look, this is what we have right now. And I don't know if you have your textbook, but this is what we're gonna be doing. There is a load and we assume fixed. So the moment on the left, if this is exactly in the middle, the moment is going to be PL over A. And this moment also PL over A. The one on the left, negative, the one on the right, positive. So I have computed for you. Look, the load is 20, the span is 8, and During the exams, I always find that people consider, look, this is the span, L. It's 8 meters, and people put 4. Remember, 8 is the span. And so, moment from BC minus PL over A, P is 20, L is 8, so minus 20 kilonewton per meter. The moment on the right-hand side is plus PL over A plus 20 kilonewton per meter. So I'm going to set up the equation. These are the two slope deflection equations. For AB and BA, this is what I done. 2E over L, 2 theta A plus theta B minus 3 delta over L. Minus is going to be fixed moment AB. On the right-hand side, 2EI over L. I'm going to move this to here. Theta A plus 2 theta B minus the same number. And this is the moment on the right-hand side. So these are the two equations. And these are the equations that I have shown to you today. So what I have to write? I have to write MAB. I have to write MBA. I have to write MBC, MCB. In my equations are functions of theta A, theta B, theta C, and delta. So as part of my equation, it's going to be theta A, theta B, theta C, and delta. But in our case, theta A is going to be 0, theta C, 0, and delta. So how many unknowns in my equation have theta and delta? How many unknowns do I have in my equation? Anybody? Anybody? How many unknowns do I have in my? 2. Okay. And 4 more. Which one are the 2? You can write it.
Theta A, theta B.
Theta B and what else? Say that again?
Theta A and theta B.
And delta. Okay.
Oh,
Now,
okay.
I don't want to tell anybody that you are confused, but look, theta A is 0. Theta B different than 0 and theta C, and delta. What is delta here? 0. So again, how many unknowns do I have in my equation deal with theta A, theta B, theta C, and delta? How many unknowns do I have in my equation?
1.
Only 1.
Theta
Right?
B.
Yeah, theta B. And that's important to know because these are called displacement method because we're going to use theta and delta. I'm going to set up my equation. Look, MAB, 2EI over L, 2 theta A plus theta B minus 3 delta over A. So this moment here, MAB, 2EI over the span, 2 theta A plus theta B minus 3 delta over A. Why I don't have a fixed moment? Why I cannot find in this table a fixed moment? Why I cannot find fixed moment for this? Anybody? Why there is no fixed moment for this? Why I don't put it? Look, my equation. 2E over L, 2 theta A plus theta B minus 3 delta over L, and no fix them all. Anybody? I give you bonus next semester. Come on. Okay, no bonus for anybody. The reason is that no load. No load in the span, no fixed moment. No load, no fixed moment. So you can see MAB, 2E over L, 2 theta A, 0, theta B, different than 0, 3 delta over A. We're going to compute this. When I finish computing my moment, what do I know about moment on this side, moment BA, and moment on this side, moment BC? What do I know? Because look, I'm going to write NBA 2EI over A, only theta A plus 2 theta B minus 3 delta over 8, no load. So I had MAB, MBA, MBC. Now I had theta B and theta C. So MBC here, 2EI over L, 2 theta B plus theta C minus 3 delta minus, now I had a fixed moment, PL over A minus, because the moment on the left-hand side this moment on the left-hand side is counterclockwise. So it goes into my equation. A minus PL over A. Look at MCB. MCB, 2EI over A over 8, theta B plus 2 theta C minus 3 delta plus the moment, because now it's clockwise, PL over A. So all the zeros are gone. You can see in here that I have written MAB, MBA, MBC, and MCB in terms of theta A, theta B, theta C, and delta. Theta A and delta 0, theta A and delta 0, theta C and delta 0. So what do normally do equilibrium at the joint? The summation of the moments at this joint has to be equal to 0. Summation of moments at any joint has to be equal to 0. But I have in here MBA plus MBC. Look, we assume that all of them in the member, they are clockwise. At the joint, when I do equilibrium at this joint, what is going to be the direction of the moment? If in the member is clockwise, anybody, what is going to be the direction of the moment at this joint? If the member is clockwise, what is going to be the direction of the moment in here? Exactly, opposite to this. So I have put in here the joint. Equilibrium at the joint. The joint is B. Moments in the opposite direction, BA becomes counterclockwise, BC counterclockwise. And there is a reaction here. Also, there is a shear force that this time is 0. That's why we only add the moments. MBA plus MBC is 0 because it has to be in equilibrium. This is equation 1. How many equations do I need to solve this problem? How many equations do you think that I need to have to solve this problem? How many unknowns do we have in this problem? Anybody? One unknown, one equation. So MBA plus MBC. MBA plus MBC, and combining these two. MBA plus MBC, I'm combining these two, and this is what I have. Look, MBA I want to increase this a little bit because this is a very important step. MBA 2EI, this is gone, this is gone. So 2EI over A times 2 theta B, MBA, plus MBC. MBC two EI over A times 2 theta B, this is gone, minus this is 20. One equation, one unknown. And I want to mention this again. EI always we're gonna leave it as a constant because it's gonna drop out. So we leave it as a constant, but theta B is 20 over EI. So what we find is a rotation, and we're gonna use the rotation to compute the moment. So theta B, 20 over EI, theta B, we're gonna put it in here, the EI is gonna drop. Theta B, we're gonna put it in here, EI, and theta B is gonna be put in here and here, the EI drop. So what I obtain is this. When I replace the value in my equation, I find that the moment AB 5 kilonewton. The moment BA is 10 kilonewton, and they came positive. Moment BC minus 10 kilonewton meter, CB 25. This came negative, this came positive. So this in here, the moment AB and BA, there was no loaded in the span. I have 5, I have 10. My check is at the joint B had to be equal amount. And this could be positive, it could be negative, but how do I obtain this value? I did equilibrium at joint B, equilibrium at the joint. MBA plus MBC equal to 0. My only unknown theta B, 20 over EI. If it comes negative, you leave negative. Don't change the sign. And I put this value into my slope deflection equation. I put that value into this equation, and I obtain this. Any question up to this point? And this 4EI, 2EI theta, the delta 6EI, the computer, they use this to set up huge problem. Any question up to this point? One. I don't know what visual. Anyway, so how do we interpret this result? You put a line, A, B. So that is gonna be your span. Moment AB 5. Which direction do I need to put in here? It came positive. So clockwise or counterclockwise? What direction I need to put, because it came positive. I need to put it in here to compute my reaction. clockwise. Oh man, Miguel, clockwise is positive. And BA 10. Which direction? Clockwise or counterclockwise? This 10 that is positive. 10 is positive. This is positive. And this is positive, clockwise. And as a rule, most of the time, whenever you have no load in the span, these two moments, they're going to come in the same direction. To compute the reaction or the shear force, they have to be down, that has to be up. Right? And I'm going to interpret the next moment. B and C, that is my span. BC came as minus. So what is the direction? And this is minus. What is the direction here? Counter. And MCB came as positive 25. What is the direction? What direction? Go. I have my load in here. I had a load given, so I'm going to compute this. So this is the way we interpret the result. And look, it has to be equilibrium. B and B, this is the same point. Clockwise, counterclockwise. They have to be equal and opposite. So on the next page, I have done this for you. For indeterminate structure, we go back to what we did the very first day of class. Everything is going to be plotting shear and moment drag, and sometimes computation or deflection or indeterminate structure. So look, this is what we had, the 5 and the 10. If you apply moment about this point, you add in 10 to 5 and divide by this span. Give me 1.875. The computation of the reaction, we had 10, we had 25, and we had the load in here. The computation of the reaction is the same way that you compute any reaction. Look, this value plus this value is the shear. It's this shear and this shear, the reaction. It's going to be the reaction in here. So this is going to be the total reaction. So individually, we compute this reaction and we do our shear diagram. And after that, look, this 5, where is the compression, top or bottom? Look, where is the compression, top or bottom? Here, the 5. Top. That's why it has to be here on the top. Look, where is the compression, top or bottom? This one. Compression, top or bottom? Bottom. That's what we had. And look, 5 minus 15 put us in 10. Exactly what we had in here. 5 minus 15, 10. For this one, we computed the reaction. It's very simple. To compute the reaction, you apply moment about C or you apply moment about B. Always, you're going to have one unknown. Once you have found the moment, only one unknown. So you have to be careful with computation of your reaction. And we had a shear diagram. Look, 10, where is the compression? Top or bottom with this 10? Anybody? Bottom. And so minus 10 plus 3250 put me in 2250. This area is 4750. 2250 plus minus 4750, 25. And that was exactly, look, 25. To compute this 25, I did not use the 25 in here. But I'm checking. I assume that I don't know, and I check that it's 25. And not only that, consistency. Where is the compression in here? This moment, putting compression top or bottom? Bottom. That's why it had to be at the bottom. So it's very simple to solve for the theta whenever we don't have too many unknowns. Because right now we have one equation we want to know. If we had theta B and theta C different, two equations with one. If we had sometimes delta 3 equation. So you can have in here 10 equations with 10 unknowns. So in the old time, before you were born, before your parents were born, we used to have 10 equations with 10 unknowns that we had to solve. So really, this was not a very popular method. It became, nobody wanted to use it until they developed a computer. Because now the computer, you calculator, you can solve 20 equations with 20 unknowns. But this is a fundamental how the computer programs are setting up matrices by using the 4EI, the 2EI, the 6EI. Any question before I continue? So there are situations, for instance, I'm going to create a problem for you, the same way that I create problems in the exam. So I'm creating a problem for you. And tell me, is this determinate or indeterminate? The load is not important. Determinate. Okay. So how many unknowns do we have in here? 2, 3, 4, 5 unknowns. How many equations do we have to solve for 5 unknowns right now? How many equations? I have 5 unknowns. 3. So 5 minus 3, second degree of indeterminate. I'm going to put a load. So look, now we're going to decide. Is theta A different than 0 or equal to 0? Theta A different than 0 or equal to 0? Different. There's going to be a rotation. This is going to form this is going to be our deflected shape. Theta A different than 0. What about theta B? Theta B ain't gonna be different than Z. Theta C, different than Z. Theta D, different than Z. And delta equal to 0. So if all are, yeah, let me go good. All of them, they're different. So how many unknowns do I have based on the theta? Four. So to solve this problem, I need 4 equations with 4. However, no matter if I do 4 equations with 4 unknowns, when I finish, I computed before. In the previous problem, I computed the moment AB, the moment BA, the moment BC, the moment CB. And I computed those and I was able to plot this. There is a moment at AB, there is a moment at BA, BC, and C. Going back to this problem, we had 4 unknowns, I need 4 equations. But no matter what I do when I finish my 4 unknown with 4 equations, what is going to be the moment? What is going to be the moment AB in here when I finish? When I do use a computer or I send it to China or any place to solve my problem. What are they going to tell me or what do I conclude? What is MAB? The moment AB is going to be equal to what? Anybody? When I finish. Before, my moment was 5. I had a moment. Because my problem looked like this. I had a moment. So now, after I paid thousands of dollars for somebody to find this answer for me. Final exam. What is the value of MAB? Moment should be 0 because it's not the fixed support. So the moment has to be 0. Why do I waste my time computing this when it's 0? And what about the moment here? What is the moment in here when I finish 4 equations, 4 unknowns, or I go to solvemyexam.com and then what is the moment, the value of the moment? 0. Okay? So I don't have to waste my time, but I do have a moment in here. I had a moment in here, and I had a moment in here. MBA is going to be equal and opposite to MBC, equal and opposite to have equilibrium. And MCB is going to be equal and opposite to MCD to have equilibrium. So in reality, I only to compute this moment, I only need to find theta B and theta C because I had 2 unknowns and 2 equations. So what we had to do is something that is going to reduce the amount of work in this method and the next one. And this is called stiffness modification. For when the stiffness is modified, the carryover factor is going to be equal to 0 instead of 1. Bijo, I made you question. Why what? You still there? I missed your question. Why is 0 at 8? Okay. We're talking about the moment, right? This is a pin support at the end. This is a roller support at the end. So the only support that can develop a moment is a fixed support. A wall will develop them. If it is a roller or a pin, there is no more. So when we know this, or if you're solving an exam and you find a moment in here before you kill yourself, you have to check your computation because there is a computation error. So whenever we look at this and we want to reduce the number of nodes, we modify the stiffness. The carryover equal to 0. I'm going to show you. I know that you need to go to a different class or have dinner or whatever, but I'm going to show you how we started today. And this is very, very simple. And I am convinced now that you're learning more. When I look at the results of the exam, you're learning more online than you were learning before face to face. It seems to me, maybe I'm wrong with just one exam. Right? But if you remember how we started, we said, look, there is a theta, there's a rotation, and we assume that it's fixed. And whenever you look at this support, a pin, because we're letting this, it was fixed, we're letting it rotate. So to rotate, we need a moment. But the far end is fixed. That's why whatever I put in here, 50% goes to the opposite side. But it's the far end. The far end where the end or the beginning of this pin. So is this where a pin or a roller? What would be the moment in here? Is this where a pin or roller? What would this moment be equal to? 0. So what is the value of the carryover factor? Instead of being 1/2, what is this value? 0. So we're gonna modify the stiffness and like I said before, it's for an undergraduate student. Not too many of you are interested on this, but I just want to show you, we already know by using common sense. By using common sense, we already know that the moment is here 0 and moment 0. So we're using common sense. But mathematically, this is what we have. The end span. We let it rotate, but now in here, there's no moment. So I went through the same computation as before. This is already a determinant. So this reaction is going to be MA divided by span. And so when I apply moment about this n, 0. So carryover factor equal to 0. When I use the rotation to do my computation, and I don't want you to go crazy trying to understand this. It's very simple because it's virtual work. But at the end, look, this is what is important. Instead of being 4EI theta A over L, and instead of the opposite being 2EI theta A over L, it's only 3EI theta L over L. So whenever we modify the stiffness, we no longer use 4EI, we use 3EI over L. And that will mean that the carryover factor is 0. That will mean that whatever moment I put at one end, nothing goes to the other. And you do need to remember this because it's going to save your life in the final exam. Whenever we modify the stiffness, carryover factor is 0. Whenever we modify the statement, we have to use the 3E IOL. And here is the proof. It's not that much difficult to follow. Any question? Okay, look, I'm exhausted and I need to continue working at grading exams. So make sure that you read what I'm going to do on Wednesday, because what I'm going to do on Wednesday is moment distribution. And moment distribution is the easy method there is to solve for indeterminate structure. Moment distribution, if you are in a situation that you don't know what to do with your life, that you want to drop the course, that you are desperate, moment distribution will save your life. So make sure that on Wednesday, come on time, pay attention, and ask questions, because moment distribution is what will solve any indeterminate structure quick, and it's an approximation, but it's a very good approximation. Okay, any question? All right. So, well, we'll see you. You're welcome. We'll see you on Wednesday. Good night. Test 2 grade, the area of the 2 grade on Blackboard. Look, but I have not found, I haven't finished grading, right? But if I done both of you, you add the two numbers and divide by 20, and that's you grade. Anybody? You're welcome. Any other question? Gracias. Could I submit internet project still in design by tomorrow? Hey, listen, I know that you under a lot of stress. So yeah, do it tomorrow. And if you cannot do it, just send it to my email. I'm gonna hate you, and no choice. Any other question? I missed the first 20 minutes of class. Are you posting online? Well, I don't have it. Somebody's gonna send me the recording later. And so I'm not able to recover next semester. You come back, I'm gonna be able to record it. Somebody will send it to me. No, no. Any other question?
Professor, the stiffness modification, is that a different handout? Because I didn't see it as part of the download on Blackboard.
The what?
You were just going over the stiffness modification?
Yeah.
Is that on Blackboard?
It's in Blackboard. Yeah. This is everything that I posted, everything that I'm using is in Blackboard.
Is that a
and the lecture for tomorrow I posted last night, or for Wednesday. But this is already in Blackboard.
Okay.
This is, you have not found it?
I don't see it. I downloaded the stuff that you were going over today, but
It's not there?
Yeah, I don't have that.
Okay, so
Is that a different download?
is that the only thing that is missing?
That's the last thing I have on here is the example that you have,
Yeah.
and after that I don't have anything part of
Okay.
that
So
download.
if it's not there, I would give me like 10 minutes.
Okay, thank you.
Bye.